Hello everyone and welcome back to my class. We're going to study today complex numbers. On previous lessons, we did study how to solve quadratic equations by using quadratic formula. And we noticed that not all quadratic equations have real number solutions. For instance, if we have equation x squared equals -1, we have no real solutions because square root of -1, it is not a real number. So to overcome this problem, mathematicians create an expanded system of numbers using imaginary unit. Let me define what is imaginary unit. It's denoted as a letter I equals square root of -1. Imaginary number or imaginary unit. Notice that when you squaring I squared gives you -1. So how I can rewrite then, for example, I have square root of -5. We're going to rewrite this number as an imaginary unit. For doing so, let me recognize that -5 we can write down or break down as a -1 times 5, right? Well, then we can break it down further, -1 times 5. By definition, square root of -1, that our imaginary number, and we can write down that square root of -5, we always can rewrite in terms of it is I square root of 5. By definition, complex number written in standard form is a plus bi, whereas a is real part and bi imaginary part of complex number. Next, we're going to practice how to add and subtract complex numbers. And this is first example for you. I have complex number 4 minus I, and we're going to add another complex number, which is 3 plus 2i. Well, first of all, we can open parentheses, 4 minus I plus 3 plus 2i. And next step, very simple. It's like combine like terms. So we're going to combine real parts and we're going to combine together imaginary parts. The final answer will be 4 plus 3, 7. Negative I and plus 2i gives us I. So we're going to put plus I. And that would be our answer. It is in standard form. It's like A plus BI. So next, in this example, we're going to subtract two complex numbers. The same thing, we're going to open parentheses and then combine like terms. The first parenthesis, we can open 7 minus 5i. The second parenthesis, pay attention, we're distributing negative sign. So we will have -1, negative by negative, positive 5i. Next step, we're just combining again real with real, imaginary with imaginary, and we will have 7 minus 1 gives us 6, negative 5i and plus 5i. That cancels out, right? So that actually our answer. So the final answer, we have 6. Take a look. We're going to work on this problem. So the first, we're going to again open parentheses and then combine like terms. Let me start doing so. 6. So we have to distribute negative sign. Of course, we have to change signs on opposite. Would be plus 2 minus 9i. So this is plus, so we have negative 8, not changing sign, and plus 4i. Next step, we're going to combine like terms. We have 1, 2, 3 real numbers, and we have 1, 2 imaginary. We're going to combine corresponding. So 6, 2, and negative 8. It gives us negative, so let me put, it's actually 8 minus 8. They cancels out, right? So negative 5i and plus 4i, we have negative, 5i. So we have only imaginary part. We don't have real part. And in this case, we have pure imaginary number. And here is another one. We're multiplying two complex numbers. It's the same way like you would multiply two binomials. So you remember it's FOIL, or I would say each term of the first parenthesis multiplying by each term of the second. And I show way how we're going to multiply. So 7 times negative 1 gives us negative 7. 7 times 2i gives us positive 14i. Negative 4i times negative 1 gives us positive 4i. Negative 4i times positive 2i gives us negative 8i squared. Beautiful. Going to work out, first of all, we can combine like terms already on this step. Let me continue here. So at this time, I will just rewrite negative 7. We're going to combine 14 and 4 gives us plus 18i. And pay attention that I square equals negative 1. So to work out, negative 8 times negative 1 gives us positive 8. And last step, we're going to combine real parts. Negative 7 plus 8 gives us 1, and plus 18i. And this is our final answer, result of multiplying those two complex numbers. The next one, we're going to multiply 6 plus 3i times 6 minus 3i. All right, let me first multiply two binomials or two complex numbers. Then we're going to notice something and we're going to discuss. So the first, we're going to do the same steps. FOIL or multiply each term first by each term second. So 6 times 6, 36. 6 times negative 3i gives us negative 18i. 3i times 6, positive 18i. And 3i times negative 3i gives us negative 9i squared. We're going to continue. As we see, those parts with negative 18i and 18i cancels out. And pay attention again that I squared equals negative 1. So what we have final, 36. And that negative 9 times negative 1 gives us positive 9. And final answer, we have 45. As you see, we have a real number. And let me derive one very interesting formula. I want to remind you one of the special cases when we have difference of two squares, we can factor in way a plus b times a minus b. In this case, that's what we have, like a plus bi, a minus bi. So we can write down as a difference of two squares. So first term squared minus second term, which we have bi squared. So let me a little play with this. We understand that I squared gives us negative 1. So let me just write down one more time. A squared minus, when we're squaring this, we have b squared times I squared. And we remember that it is equals negative 1. So we will see the result. We have a squared minus times minus plus b squared. And that is very important, very interesting what we have. So let me give you one example. When we're multiplying conjugates, one more time. For example, let me pick the color. Yeah, I like this one. So, for example, very quick. I have 5 minus 2i times 5 plus 2i. So the result we have when we multiply two conjugates, we actually have a squared plus b squared. Our a is 5, result would be 5 squared, plus b is 2 plus 2 squared. So we have 25 plus 4, the result is 29. You see, it's always real number when you multiplying conjugates. This is very important to remember because next we're going to work dividing complex numbers. With this example, we're going to study how to divide two complex number and write down result in standard form. So this is method we're going to apply. We're going to multiply numerator and denominator by the complex conjugate of denominator or divisor. So the first 5 plus 3i on divisor is 1 minus 2i. Remember, we're going to multiply by conjugate, which in our case would be 1 plus 2i. To keep the same equivalent expression, we have to multiply 1 plus 2i, numerator. But doing so, remember, when you're multiplying two conjugates, you always will have a real number. So remember, we was already figure out that it's, if we have a plus bi, let me remind you one more time, and we multiplying a minus bi, the result gives us a squared plus b squared. And we already discussed about this. So on the bottom, we will have 1 squared plus 2 squared. So in numerator, we just doing FOIL it, multiplying two binomials. In this case, we will have 5. So you can FOIL it. 5 plus 10i. Now we have 3 plus 3i and plus 6i squared, correct? Continue working. On the bottom, we already can have a number which gives us 5, right? And here we're going to work out. So again, remember that I squared gives us -1. So first of all, 5 at this time, we rewrite. I will rewrite one more time. Combining those imaginary parts gives us plus 13i. And as we discussed, that 6 times -1 gives us -6. Next, 5 and -6 gives us -1 plus 13i over 5. In last step, we're going to rewrite in standard form, separate real and imaginary part. So we will have -1/5 plus 13 over 5i. And that would be our answer. So remember, the method when you're working with dividing two complex numbers, that you have to multiply numerator and denominator by complex conjugate of divisor. And that would be your rule.